I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on the 2024 AP Physics 1 exam. This is question 5. In this video, we're going to talk about the AP Physics exam, AP Physics 1's 2024 exam. This is the FRQ section. This is FRQ number 5. So in this scenario, we have two blocks, one stationary, block B, with a mass of 2 kilograms, and block A is moving with a mass of 6 kilograms. And it doesn't tell us how fast block A is moving. It tells us block B is stationary. It also tells us that all frictional forces are negligible. And what we're to determine is the speed of block B immediately after the collision. So we know there's a collision, and they collide elastically, which means that kinetic energy is conserved. So because we don't have the block A's velocity before the collision, that means we can't use conservation of momentum. But what it does tell us is that block B has an kinetic energy value of 9 joules after the collision. Because we know it has 9 joules and we know that it has a mass, we can just simply use the kinetic energy equation, K equals 1/2 mv squared. So we can rearrange that equation and solve for velocity, which is equal to the square root of 2 times the kinetic energy divided by the mass. Then we can substitute the values in, 2 times the kinetic energy of 9 joules divided by 2, and that's going to give us a velocity of 3 meters per second. So that means block B is moving at 3 meters per second after the collision. Now for part B, it's asking us to draw a graph. So it's showing us that the block's velocities and positions as a function of time. And block A is starting at a position of 0 and moving for 1 second. It moves 2 meters in 1 second. So now we know that the velocity of block A before the collision is 2 meters per second. Block B is not moving, so it has a velocity of 0, so its position is staying the same. And we have this dashed line that represents the velocity of the center of mass, or the position of the center of mass. And what we're asked is on the graph in figure 2 to draw and label 3 distinct lines, one that represents block A, one that's block B, and the center of mass of the two block system as a function of time between times 1 and 2. And each line should be distinctly labeled, so make sure you label your lines. So block B has a velocity of 3 meters per second, as we calculated back in part A. So the slope should be 3. So that means if it's at a position of 2, it's going to end at a position of 5 in 1 second. So there's our line for block B. Now the velocity of the center of mass does not change when momentum is conserved. Well, there's no frictional forces. So that means that it's going to continue to be the same line. So all we're going to do is extend that line, and that's the velocity of our center of mass. Now, for block A, we know its velocity before the collision is 2 meters per second, but now we need to figure out what is the velocity of the block A after the collision. So we're going to use conservation of momentum. So we set the momentum before the collision equal to the momentum after the collision. So we've got two things moving after the collision and only one before. So the momentum of A initial equals momentum of A final plus the momentum of B final. We substitute mass times velocity in for each of those, substitute our values in. So we know that A is moving at 2 meters per second because that's the slope of the line that we have for block A from figure 2. And so 6 times 2 equals 6 times the A's final velocity plus 2 times 3. So we can solve for velocity and get that A's velocity is 1 meter per second. Well, what this means is that it's going to move 1 meter, so it's going to end up at a position of 3. And why is that? Well, that's because the slope of this line is 1 meter per second. So the slope is going to be 1. So there's our third line for block A. And we've labeled each of them as it said. So this is probably worth 3 points. It could be worth as many as 4 points. And assume part A is only worth 1 point because it's just a calculation. So part C is asking us to consider the original scenario, but now instead of colliding elastically, they collide and stick together. So a perfectly inelastic collision. Now, this really doesn't matter because in all collisions, momentum is conserved. And we want to know if the velocity of the center of mass is going to be any different. And the answer is no, the line's not going to change at all because the velocity of the center of mass does not change when momentum is conserved. And since there's no frictional forces, that means there's no external force causing an impulse, so momentum is conserved. So the line for the center of mass is not going to change. A side note, to calculate the velocity of the center of mass, that is equal to the sum of all the individual momentum, and then we divide that by the sum of all the individual masses. So in this case, the individual momentum is always going to equal 12 because there's no external force, because the velocity of block A in the beginning was 2. So 6 times 2 is 12. So that's always going to be the momentum. And the mass is always going to be 8. So 12 over 8 is going to give us 1.5. So the velocity of center of mass is always going to be 1.5 meters per second. So this is AP Physics exam 2024 FRQ number 5. I hope this was helpful, and I hope you have a great day and even better tomorrow.
If you found this video helpful, click the like button down below and subscribe to my channel, Happy Coaches, and follow me on Instagram and Twitter at Happy Coaches.